Hello everyone. In today's video we are going to have a discussion on multidimensional arrays. We have seen in the previous videos about arrays and indexing of arrays, how to we store the values and retrieve out of arrays. Now multidimensional array is you can say is an array of arrays. Okay, an array of arrays. Meaning is that we have created array in which whatever the size of the array you declare, and you can have multiple items of similar type. Now what if I want to store a matrix? Okay, a matrix which is in the form of rows and columns. For that type of scenario, I will be needing some data structure in which I can store the data in row and column format. For that purpose, we have multidimensional arrays, and for matrices, we use two-dimensional array. Okay, two-dimensional array. Often we write it as 2D, okay, most of the time. For example, if I declare float x and if I write like this, this is a two-dimensional array which can hold 12 elements or items, right? Here this 3 is representing, okay, this 3 is representing rows and this 4 is representing columns. Okay, now if we want to see, we can see that in terms of, let's make a tabular structure for it. Okay, if I want to see in that, so I have to divide in the format of rows and columns. Okay, fine. So then I will be having this as row 1, row 2, row 3, and here we have column 1, column 2, column 3 and column 4, because this is the structure here, a 3 by 4 which we have written, and we want to hold within it 12 number of elements. As you know that the indexing in array starts with 0, so the first element, this is representing x 0 0. Okay, the next one will be 0 1, this will be 0 2, and this will be 0 3. So we have 4 columns, so indexing will start from 0, then it will go to 3. Here this will be our 1 0, this is 1 1, this is 1 2, this is 1 3, and likewise 2 0 2 1, then 2 2, and then finally 2 3. Now these indexes are used to access the value of a particular row and column. Suppose if I want to fetch about that what is the value of row 2 and column 3. Now remember this 3 cross 4, we have number of rows 3, number of columns 4. Now when I say row 2 and column 3, that means out of this I want to actually check row 2 means this middle row I am talking about, and column 3, that is this. So particularly we are interested in fetching this value. So for fetching this value, when we have row 2 and column 3, remember this is lesser value in index because the indexing starts from 0 itself. So we will be identifying x, and what is our index? x1, 2, and this will result us to the value of row 2 and column 3. This is how we declare our two-dimensional arrays. We can have three-dimensional arrays as well. Okay, simply you need to increase here another dimension, but for now let's work with two-dimensional array. And this two-dimensional array is nothing but a representation like matrices. Okay, so matrix. Fine. Now let us take the example of matrix. So I have written two matrix over here, and which is having dimension 2 by 2 because we have only 2 number of columns and 2 number of rows. Now I can have any operation on these matrices by holding the data in multi-dimensional array. So suppose I want to have addition of these matrices, then what will happen in this case? This is my matrix number 1, M1, and this is my M2. Now if I want to store the data, then and if I want to perform the addition will be like this: M1 and this is our 0, 0 will be added to M2 0, 0, and likewise we will be adding the values of M1 10 plus M2 10. Same row and column will be added. Okay, so the data representation will be of these matrices will be like M1 will be of 2 by 2 and M2 is also of 2 by 2. Okay, so here I am going to write your first assignment over here, which you have to perform in your lab. Fine. So this is your first assignment of today's lab. Write a C program to add two matrices using multi-dimensional arrays and display the result. So the idea is you please make two matrices, that means two multi-dimensional arrays holding the values, and then perform the addition of them and then display it using a loop. Now remember, whenever you are performing the addition, the dimension of the two taken matrices should be of same. Like if you will change here M1 to 2 cross 3, then the addition won't be possible. It will be possible when both the matrices are having same number of elements. Let's proceed to another use of this multidimensional array with respect to matrices itself. that is, let's talk about transpose of matrix. Transpose of matrix is row is changed into column and column is changed into row. Suppose I have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have this matrix, then its transpose will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is transpose. Fine. So the idea is that the element, let's say my matrix is M and I is my row and J is my column. Okay, let's mark it. This is my row and this is my column. Then what I will be doing, I have to convert it into where my, now this becomes like this, that now this is the value of row and this will be value of column. We switch it. Okay, like here, let's say for first element it will be remaining same because it is 0, 0. For diagonal elements, this is 1, 1, this is 2, 2, this will be remaining same. But for in case of transpose, suppose for this element, earlier it is, if we want to access, it is row is 0 and column is 1. Whereas in this case, when we transpose it, then what will happen? The row will be this and the column is this. Okay. So remember, in case of transpose, our diagonal elements, they will be remaining on the same position, but the value for row and column indexing will change for the other values. So we know that what we have to do in case of this, right? This is the logic. So now I'm going to give the second assignment for this lab. So your second assignment for today's lab is write a C program to print transpose of a matrix given by user. So first you have to ask the user to enter a matrix. Definitely matrices, two-dimensional array you store it in, and then you have to put a logic of this, that you change or you switch the rows and columns. After switching, you need to keep it in the let's say in another matrix or in the same, and then you print that result. Okay, so that's all for today's lab. We have done multidimensional arrays in which we understood the indexing part, and two problem implementation you have to do in this. Thank you for watching.